Hello and welcome to the first tutorial in CS 4010, the finite element analysis and structural dynamics. So in this tutorial, we are going to make a simulation of a bridge. It's a chart. So in the workbench on the left column, you click on the static structural, and the first component is about the material properties. We don't click on this, we click on the geometry to start drafting geometry. This tutorial is inspired by a new painted chart I saw when I drive from Townsville to Brisbane. So here is the interface of the space claim. The first thing we have to do is to select the plane we are going to draw on. And I change the view to the front view. I also have to change the unit to meter. So I choose the option and then select unit and then change it to meter because the chart is in scale of meter. I also need to change the grid to about 0.1 meter for easy drafting. Okay, so charts consists of elements. I have to draw elements. Here I use the line tool and I enter the length of the line is about 4 meters. And I keep drawing other elements of the chart, and it may be easier to be in the Cartesian coordinates. So I enter the distance up between each point and keep drawing the vertical and the inclining elements. So these elements belong to one group, and I create a new component for it. I call it 100. This is the name of the cross sections, and I move all of these elements into this component. I also create a new component for a bigger elements, so I call it 200. And I use the line tool to draw the horizontal elements. Please remember that when you draw in a component, you must make it an active component. Okay, so now I already finished a pattern and I need to copy it several times. How to do that? I select all element of an active component and then add up other members elements from other components. And then I copy it by clicking on the pattern button. I need 4 copies, and the distance between pattern is about 4 meters. And I also need to select the direction, which way I want to copy, and I approve it. So now you can see I have few patterns, and I finish the last one. Now I finish one side of the chart. I need to copy to the other side. So I move to 3D perspective and then select all of the members and elements in the components, and then shift select all others. And I can use pattern, but I don't have the direction yet, so I use move control and drag it to a new position. Lift up your control before you enter the space. Here I have the space is about 7 meters for 2 lanes and the pavement. Okay, so now I need to draw the beam underneath and on the top to connect these two sides. and I copy it by using the pattern. I need 9 bars and the distance between them is 2 meters by this direction. Note that I'm going to make a typical mistake in design by selecting the inappropriate cross-section area for the bottom elements. So this element must be bigger to be safe. For the top elements, I'm going to draw it with a plane. You can draw it directly, but in this tutorial, I guide you how to add up a plane. So click on the plane and add on the element you want to have on the top. And then you use the line tool. You have to select the plane you want to draw on. And then draw an element to connect two sides and copy it by the pattern as we did before. So now I finish the drafting. What I need to do in the next step is I want to convert them into beam, not only line, but the structural beam. There are two ways to do that. The first way, I select all of the beam I want in the component 100 and then click on prepare and then add cross section for it, rectangular. You can keep doing that by make the other component active and then select all of the lines in that component. However, in this tutorial, I'm going to guide you the second way, make the cross-section first. So now I change the cross-section name to 100 so I will not be confused later. Now I add a new cross-section area first. And then edit it to 200. I also need to change the geometries of each cross sections by right click and then edit property. For the 100, it's already 0.1 meter, so I don't need to change anything. Now I change the properties of the 200 cross section area by clicking on the respective dimensions and change it to 0.2. So you can see it rectangular now and it's become square now. I zoom it in so you can see, and the dimensions is 0.2. Now what I want is I have to go back to structure and then select all of the line in the second component, the 200. Click and then shift, click, and I have to select the right cross sections and click on the create button. So now you can see all of the lines have been converted into beams. So now I have to change the topology to share node, so all of elements are welded at the end of the Truss element. And I finish and I move to the model. So in the model, I have to generate the mesh, and you can see that this is a frame of our Truss. The bottom elements are very thin and it will cause a very big deformation later. To start the analysis, I firstly need to add some special constraint first. So I have to add some support. Firstly, I had to add some fixed support to one end. So to select the node, I have to use the vertex and then click on the vertex I want to apply on and then apply. For the other end, I use the hinge support, so I use a simply supported model and apply to the other two nodes on the other end. Apply. And you can add up some load distributed and point load. But in this simple simulation, I just add the standard gravity, and by default it's by minus z direction, so I change it to minus y. And I need to conduct the solution to see the deformation, so I select the total deformations. Because I have only beam, so therefore no stress analysis, only deformation analysis. And if you have the shell elements, you can do it later. So you can see here, the two sides of the truss have almost no deformations. However, the middle spans had a very big deformations. You can fix this by increase cross-section area or by add up some additional elements. Thank you for watching and see you next time.